Okay, so let's talk about planets. So first of all, what do you know about planets? People? Wilkes? They're very diverse. Ooh, yes. They are very diverse. We will talk about the diversity in planets and how different they are. What else do we know about planets? Any ideas? Let me ask you a more specific question. Could you define planet for me? What do you think? Could you make a definition for a planet?
I guess a large rock, probably like large rock.
All right, Trent goes large rock, huh? Large rock. Okay, like how large? Are we talking like smaller than a star? Bigger than a star? What? Large rock. Okay, that's an interesting definition. Any other possible definitions of planet? Large rock? Yeah, Bliss?
Large gas, but less often than stars.
Large gas. Large gas. Gas? There we go. Question mark? What other ideas do we have for what a planet is? Okay, a body in space. A body in space held together by gravity without fusion. Fusion? Is that a pretty good definition that we just came up with there? Yeah. Okay, that's a pretty good one. Orbit? Question mark? Okay, so if we can't define it, can we make a definition? If we can't make a definition, could we make a list of criteria? Criteria that make a, whoa, hello. Hello. Yep, can do. Bye, Trent.
Wait, what?
You're being checked out. I don't know. They don't tell me these things. They don't tell me the reasons. Okay. So could we make a list of criteria for a planet? How about criteria? Let me make this bigger. Could we make a list of criteria? So I think that held together by gravity, that's a pretty good one. And no fusion, that's a pretty good one. Because if there's fusion going on, it's a what? It's a star. It's a star, right? So it doesn't have any fusion. It's held together by gravity, okay. By gravity. It's big, apparently, according to most of you. By gravity? How about gravity? Ugh. By gravity. It has significant mass. Okay, so it's thick. Has mass. Yeah. This is pretty good. I mean, this is a pretty good list, right? So you think that if we took this list to astronomers, they'd be like, yeah, that sounds like a planet. Maybe? Could also be a moon. Okay, so how do we differentiate it from a moon? A moon has to be orbiting a planet. So this is like doesn't orbit another planet. Doesn't
Can it be orbiting the sun?
orbit. Okay, so we could doesn't orbit other planet. Orbit sun. Or I guess we could say star, yeah. Okay. That's pretty good. It's pretty good. So we essentially just nailed it as a class. Pretty good. Okay. Really, what we need to talk about is the astronomical, or I think it's like the International Astronomical Union, the IAU. They have a specific definition for a planet. And we got really close there. Definition of a planet. What is a planet? Science for kids. Okay, NASA. I want the IAU definition of a planet. There we go. Good old Wikipedia. Okay, so let's zoom in here. Is in orbit around the sun or a star. Okay, in our solar system, it has to go around the sun. Has sufficient mass to assume hydrostatic equilibrium. We'll talk about that in a minute. And has cleared the neighborhood around its orbit. Those are the three things. Among other things, this definition caused Pluto to no longer be classified as a planet. People are still upset about this, which I think is silly because Pluto doesn't care what we call it. It is a very large chunk of rock and ice, a few billion kilometers away. It does not care. So this is the official definition of a planet for our solar system. It's in orbit around the sun. You could replace that with star. Has sufficient mass to assume hydrostatic equilibrium and has cleared the neighborhood of its orbit. This one is pretty simple, right? It goes around the sun. It doesn't go around another planet or another thing. Yes, Wilkes.
So we're talking about planets. We're talking about exoplanets as well.
Yes. So when we talk about exoplanets, which we will get to in more detail later on in the class, exoplanets are planets that go around a different star than our sun. Okay, so they're non-solar system planets. So yes, they fit this definition as well. All you have to do is take out sun and put in star. Okay, so that's what a planet is. So let's talk about hydrostatic equilibrium, shall we? Hydrostatic equilibrium. I don't really want you to understand or like remember that name, hydrostatic, because to be, oh gosh, come on, are you kidding me? Hydrostatic. I'm gonna mess this up. I know I am. Equilibrium. Maybe. Oh my gosh, it's not giving me a red line. Yay! Hydrostatic equilibrium is when something has enough gravity. Prepare yourself for one of my drawings. When it has enough gravity to pull it into a Hey, that's not too bad, right? It's pretty good. Has enough gravity. Let's change colors here. Red shows up better. To push it into a sphere or spheroid. The Earth is not a perfect sphere. It is a, yeah, it's an oblate spheroid. So the gravity pushes in, and so remember how in stars gravity pushes in and then the fusion energy pushes out, right? In planets, there's not enough energy to collapse the thing. What keeps it from collapsing is let's go with blue, is just the fact that the rocks and the gases don't want to be really close to each other. And these forces equal out in every direction. That makes a sphere. Okay? That makes a sphere. In a celestial body that does not have hydrostatic equilibrium, so and I'm just going to abbreviate that as HE. That means that what we have is something that is so not dense that the gravity doesn't quite push it into a sphere. It's a potato. Okay? So the gravitational force is very weak. Little arrows showing weak gravitational force. Okay? So what happens in a planet is that the gravity is so strong that it just squishes everything into a sphere. Okay? So it has to be large enough to be spherical. It has to have enough mass to be spherical. And then the third point of this definition is that it has cleared its neighborhood around its orbit. Okay? So what that means is that you have an orbit, right? We've got star here. Beautiful star. Okay? And then we have this possible planet candidate going around the star. Well, if there is a whole bunch of stuff like here and here and here, right, in its orbit, then it cannot be considered a planet. And this is what disqualifies the dwarf planets like Pluto. Okay? The dwarf planets have not cleared their orbits. There's a whole bunch of stuff by them. And there are several dwarf planets, and we'll talk about them in greater detail. So that's what a planet is. Okay? So just so that we're on the same page as far as planets. In 2006, which is what, like the year that some of you were born?
Excuse me, 2004.
Oh, I'm sorry. 2007? Wow, that's crazy. John was born in 2007. So John has never lived in a world where Pluto was a planet. Way to go, John. Okay. In 2006, the IAU made this definition, and we reclassified Pluto as a dwarf planet. And there are many dwarf planets that are very similar to Pluto. but everyone was like, oh, Pluto, yeah, we love Pluto. All it was is just the most popular of large non-planetary bodies.
Well, technically, it has enough mass to be spherical.
It is spherical. The problem is that it has a whole bunch of stuff that orbits in the same path as it.
So that's what makes it not a planet.
That is what disqualifies it from a planet. And there are many other bodies exactly like that. In
So they would just call it
a planetless moon? What?
planetless moon.
No, that doesn't make any sense because their moons do not have to be spherical.
Somehow like Pluto was like the Death Star or something.
Oh, if you want to talk about a Death Star, have you ever heard of Mimas?
No.
Oh, prepare yourself. Mimas, and we'll talk about moons and stuff with the planets. But if this isn't the Death Star in disguise, then I really don't know what is. Oh my gosh, come on. Oh, my computer is struggling. There we go. It's the Death Star in disguise. Yeah, so very obvious. The Empire has built, this is one of Saturn's moons. Anyway,
Seriously?
so when we talk about planets, that is the definition. Okay, next time we are going to start a discussion about the 8 planets in our solar system, starting closest to the sun. Okay. We are going to start closest to the sun. Remember, none of this is to scale. Not even close. This is actually a total disgrace of a graphic. The fact
Why are they all in a line?
the fact that they're all in a line, the fact that they're all, I mean, it's not
They that close.
impossible for the planets to be in a line, but the fact that
Size.
Mercury is bigger than Neptune,
Explain that.
this is a travesty. The fact that Earth appears to be the largest when it is actually 1/1000th of the size of Jupiter. This is an affront to everything that science stands for. I'm just pretending to be really offended. Same with this. Also, they included Pluto in this, and this isn't even an updated picture of Pluto.
That's fuzzy Pluto.
Yes, this is Pluto when we had like 3 pixels, and we're like, well, I wonder what it looks like based on these 3 pixels. Yeah, so you see these things like this all the time. This is hilarious. This is hilarious how bad of a graphic this is. None of this is to scale. If we were to do this to scale, which we will probably do next week, a scale demonstration of what the solar system actually looks like. It would look very different than this.
I remember what Bill Nye did.
Yeah, there are a series of really great. There's a lot of videos that you can find that put the scale of the solar system into perspective, and yeah, we don't have enough time to do this whole video, but it's pretty cool. Okay. Yeah, things. Okay. Maybe I shouldn't show this actually. I'm going to end the recording. You can see what this is called, YouTube people. I'm going to end the recording because if I show this, then I'll get a copyright strike and none of you will be able to watch it on YouTube. So Bye, YouTube people.